Yeah, so this is a review of the quiz that we just had this afternoon, and the quiz was just on mechanical properties of matter. So we just want to see really how we can approach questions and not panic, because really for physics or any course that you are having, that you are taking, whenever a question comes through, whenever they give you a question, is because they know you can solve it. So even if you go in a test, you find some question which looks a bit complicated, don't worry. The people who set that question believed that you have all the power, all the capabilities to solve it. You have all the tools. You have been taught in all the ways which can give you enough knowledge and wisdom to solve that question. So even for me to give you that question, it was because even the thing, excuse me, even the things that we have catered were able to enable you to solve such a question. So anytime when you encounter a question, the biggest strength you have is faith that you can do it. You know, that can do attitude should be in you. Whenever you find a question, no matter how difficult it seems, you have to believe that for the person who set this question to put it here, they knew that I could do it. And since they believed that you can do it, now it's time now for you to believe that you can do it. So let's look at the question and see exactly what we were supposed to do. So there is the question. So maybe Precious, you can read for us the question again.
The question reads, a composite of 3 mm diameters consisting of a copper wire of length 2.2 meters and a steel wire of length 1.6 meters stretches under a load by 0.7 millimeters. Calculate the load. Take the copper's Young modulus to be 1.1 times 10 to the power 11 pascals, and that of steel to be 2 times 10 to the power 11 pascals.
Awesome. Mr. Wisdom, good to have you this evening.
Thank you, sir.
Awesome. Hope your network is okay. Usually your network in the evening usually has challenges, but we hope the network is okay.
Yeah, but I doubt if it will match because it is cutting even now.
Okay. So let us review the question. The question says a composite. So composite meaning this is something that is comprising more than one material. So a composite is something comprising of more than one material. So we have a composite, meaning we have a wire, so to say. This wire has a diameter of 3 meters, and it's consisting of copper. There's a certain section which is of copper, length 2.2 meters, and another section of it is steel, length 1.6 meters. And then it is stretched. Some of you guys thought this is stress. It's not stress, but stretch. Stretches under a load by 0.7 millimeters. Then they are saying calculate that load, because they're telling us that when you put a certain load, it will stretch. But then we need to calculate that load. And then we've been told to say, take copper's Young's modulus to be 1.1 times 10 to the power 11, and then even Steele's Young modulus to be that way. So that's the question. That's the question. They want you to calculate the load. So when they give you that question, they believe that you can solve it. All right? They believe that you have all the tools, all the knowledge to solve it, to calculate that load. And they believe that they have given you enough information to actually calculate the load. Now, how can we go about such a question? First of all, we collect data, right? That's how we always do. We collect data. All right. Once we collect data, but usually, sometimes even before you collect data, you are supposed to draw a diagram. Even before you collect data, you draw a diagram. You draw that there's a load. There's a load which is hung to this wire. And then this wire has two sections. There's a certain section with a certain length, 2.2 meters. And this is copper. I've even put LC, copper. And there's another section which is 1.6 meters. It's steel. So when we apply this load, this load will exert some force, some weight, which will make this wire to stretch, right, to change its length. So this wire will change its length. Now, let's see the data that we have so that we can compute what type of load is required to make this one change its length. All right. All right. So now we have data. We have the diameter of the wire. We have which we can get the radius, which is just half of the diameter. We have the length of the section for copper. We have the length for the section for steel, and we have Young modulus for copper. We have Young's modulus for steel. Sorry, here this was supposed to be 2.2. Yeah, let's just try and sorry, change that so that people get the correct 2.2. Awesome. That's how it's supposed to be. Young modulus for steel is 2.2 times 10 to the power 11 Pascal. Yeah. And then we have been told it stretches.
Is it not 2.0, sir?
Oh, 2.0. Oh, sorry. These are mistakes that obviously even the tutor can make. You will discover that even some of your lecturers, professors, they make these mistakes. But the thing is, the concept should always be ringing in your mind, and don't make mistakes as I am doing them. Always have them. So this is what we have: Young modulus for copper, for steel. Now, we were taught something in the question that a wire stretches. So when it stretches by 0.7 millimeters, meaning it changes its length. So meaning when it changes its length, meaning some section for copper will change its length and some section for steel will change its length. So therefore I've converted the millimeters into meters, which is 0.7 times 10 to the power minus 3 meters. So when they talk about stretching, it stretches by this much. But the whole idea is for you to know that since it is having a certain section for copper, certain section for steel, meaning since they haven't specified to say, no, only the copper part stretches by this much and the steel part stretches that by that much. Since they have not specified which material stretches by how much, they have just said the whole wire stretches under a load by 0.7 millimeters, meaning this stretching is taking place with the copper and with steel. So you have to be able to have that capability to extract data from the question. Like I always say, and I always mention, I always say that spend as much time as possible. If you have been given a question to solve in 5 minutes, spend 4 minutes. 4 minutes. Try to understand the question, extract data, draw a diagram. Always draw a diagram to visualize. If you can't visualize the question, then it will be very hard for you to solve. So visualize it, draw, extract the data, understand the question by reading through more than once. And then once you really fully understand what the question is saying, you can now go to the solution to put in the formula. All right. So we have, yes.
Yeah, I've got a question, sir.
Yes, Mr. Wisdom.
Yeah, when rounding off, I mean, when moving the decimal points, what if you move it to 7? Can you please come back to the previous page? On the this one. What if you move it to 7 times 10 to the power -4? You move it to the other side of 7.
It's still fine. It's still fine. It's even if you didn't put times 10 to the power, even if you wrote 0.000007, it would still be fine. Here, the reason why this so that you just know that millimeters in meters it is 10 to the power -3. It's still, there isn't much problem there.
All right.
So now we have the formula. So now, since we are talking about stretching, force, Young's modulus, you know definitely that the formulas that you're supposed to implement are, force over area is equals to Young modulus times change in length over the initial length. And then, since they have also talked about change in length, meaning the stretching, you can also already realize that I can put my change in length to be equal to force over length over force times length over area times Young's modulus. All right. Why have you decided to put your formula like this? So that, because you know that the stretching which you were given, so this change in length which you were given as 0.7 times 10 to the power -3 is easy together the change in length for copper and change in length for steel, because you have two materials in that wire. So you add their change in length. They have two separate sections. So obviously copper was changing length by a certain amount and steel was changing length by a certain amount. And then, so since you know that that's the case, you know that you can just say, okay, change in length is equals to force times the initial length over area times the Young's modulus. But you know that change in length for copper plus change in length for steel is the one that is giving you this value. So meaning you can replace, since you know that change in length is equals to force times length over area times Young modulus. So you can now replace where you have written change in length for copper, you put the expression for change in length. Have you seen? We have put force times length for copper over area, since it's the same area, but then they have different Young moduluses, so you specify this is Young modulus for copper. And here where there's steel, change in length for steel, you put the expression for steel and say, okay, force times length for steel over area times Young modulus for steel. Now, some of you were making a mistake by adding the Young modulus. Why were you prompted to just add? Some of you guys added the Young modulus for steel plus the Young modulus for copper. You added Young modulus for copper plus Young modulus for steel. Why should you add the Young moduluses? All right, because you were not supposed, in fact, certain equations are the ones which are supposed even to tell you what you can add, what you can subtract, and what you can do. So someone can wonder, what equation did you use for you to come up even with an idea to say, okay, let me add the young. Anyway, that's not for me to maybe look down at you. It's just for me to help you to think that whenever you are doing something, let some equations guide you. And sometimes it's not only equations which should guide you. Also, even the way you understand concepts. Let me just make one statement again about Young modulus. Young modulus, it is the measure of how hard it is to stretch an object or a material. So if you add 2 Young modulus, meaning you are increasing the hardness. But if you attach a copper wire and a steel wire, you are not increasing the hardness. You are just obviously just increasing the length. You know, we had a certain length for copper and certain length for what. So if you attach them, you are not increasing the hardness. If you attach them like that, one and then another one, you put it there, you are not increasing. Maybe if you put them together side by side, maybe you can increase the hardness. But since you put one like this and then another one down, you can't add the Young moduluses. So I hope you can be able to have I can be able to open your mind up in that way. So now, but here we can add the change in length. Why can we add the change in length? Is because they told us that the stretch, everything stretched by this much. So we can add the change in length. So now the change in length is now which we are now expressing into the formula, this formula. Change in length is equals to force. Now we can put, instead of just putting length, we'll put length for copper. Instead of putting Young modulus, we'll put just Young modulus for copper. So when we add them, we know that what we are looking for is force. So we can make F the subject of the formula by factoring it out. We have force here and we have force there. We can factor it out so that in the brackets, we can just remain with the Young modulus, the length for copper, the Young modulus, and the length for steel. And then what we have in the denominator remains intact like this. So now all what you need to do is to cross multiply and make sure you multiply this to that. Now what we did here is that you know the procedure for adding 2 fractions. When you're adding 2 fractions, you first have to find the common denominator. So sometimes the common denominator is just found by multiplying the 2. All right, you multiply this one by that one, you get the oasis. Sorry. Yes. And here, actually, let me just make one correction. This is not supposed to be squared. Yeah, this is not supposed to be squared. Why is it not supposed to be squared? Just this correction. Yes. A is not supposed to be squared because area is here and there. So when we are multiplying this, when we are looking for the common denominator, you know that you will only multiply what is different. All right. So here we have Young modulus for copper, and here we have Young modulus for steel. So instead of when looking for the common denominator, we just multiply the 2 numbers. What we can do is, instead of multiplying the 2 numbers, we can just multiply what is different. The area, we just maintain it. Because so that when you do this value into this, when you say area times Young modulus for copper into what we have in the denominator, the area will cancel, and then even this Young modulus for copper will cancel. What you multiply, what you remain with is the Young modulus for steel. The Young modulus for steel. It's the one now which you multiply here Young modulus for still. And even there, you do the same. Area times young modulus for still into what we have in the denominator. What you remain with is young modulus for copper, and then you cross it. You multiply it on top. I'm sure you know the rules of adding two fractions, right? You know the rules of adding two fractions, right? So you get how we are doing it, right? Mr. Wisdom?
Yes, sir.
So
Yes, sir.
yes, so that is how we are supposed to do it. So we factorize f, and then we make it in a single fraction, and then all we need to do is just cross multiply, and what we have on the other side is this. Again, we are saying that this area. So what we cross multiply is we get this, which we have in the bottom, we'll multiply on top, and then what we have on top we'll multiply down. When we cross multiply, we have that. Again, what we are saying is that this area, as we have said already, shouldn't be squared. All right, it's coming from here. It's coming from here, shouldn't be squared. Sorry, just a moment. There. So it shouldn't be squared like that. It should be just left like that, and then where we cross multiply. So remain with your f. Now they're talking about the load. The load is the same as force. So you know you have your area, you have your young modulus, you have when you compute. I didn't want to compute the final values because actually I don't have a calculator. I use a calculator on my PC. So the thing is, you can go ahead and now compute this and multiply. So have you seen that the same concepts that I told you are the same concepts that you are supposed to apply? And it's straightforward, really, just like that. So now, maybe the question is, are you clear with the explanation? Are you?
Yes, sir.
Precious? Huh?
I'm here.
Oh, you are already dozing? I can't hear you.
I'm saying that I'm clear.
Awesome. So now, Mr. Wisdom, you didn't attempt it. So actually, you were supposed to attempt it first. I would have loved it that you would have watched the repeat video or the recorded video after you attempt it, so that I see first before you attempt it. But anyway, it's okay since you have watched the video with us. But for Precious, he attempted it. But then one thing I'm going to request from you is that tomorrow morning, hopefully God willing, tomorrow morning, I want you guys to send I'm not going to send you this PDF solution. So I want you to send me solution. All right. I've shown you the steps and I've opened your mind. So now I want you guys to go and solve it. You don't have to solve it using the exact methods, but according to where you have understood now that I've explained it. So hopefully tomorrow morning before 10, before 8, anything, when you just wake up, solve this quiz and send me the solution. All right, tonight it's already late. If you send it, I will not check it, but hopefully you can send it tomorrow morning. I will not send you this PDF of solution. I want you to send me. Is that okay?
Yes, sir.
Awesome.
And
So
you can also send another question for me so that I attempt it. But sorry, too much exercise. But it's not an exercise. This one around 8, starting from 18. we'll have the class. Tomorrow is Monday.
Mm-hmm. So now,
We're
instead of,
having the class.
yes, I understand what you're going to say. Now, instead of you, so what you do is when you just wake up, if you wake up at 6, get a pen and a paper, solve it, capture it, send it to my inbox. Before, I was saying before 8. Even if it means waking up at 5, at 4, or even solving it right now, just after the end of this lesson, I have to see the solution before 8 hours tomorrow morning. But usually, if you send it tonight, I want to look at it, I'll look at it in the morning. But yeah.
All right. Thank you very much. I'll do so then.
Awesome.
But for the remaining questions, I'll send them after 10. I'll attempt them after 10. Then I'll send them before 15.
Awesome. I guess good night, and yeah, good night. Don't forget to pray, and you should also be finding time to read your Bible. Good night.
All right. Thank you very much.
Good night.
Mm-hmm.